Hello, everybody. Today is our group will be present about the Watson and the Jeopardy challenge. We are Group 8, HaPhan, Youwei, and Van Ngo. This is the agenda for today's presentation. I will cover the first two parts, introduction and the challenges that Watson faced during the Jeopardy challenge. So the introduction, I'm talking about Jeopardy and what is Watson. Jeopardy is a classic game show with a twist. The answer was given and the contestant need to supply the question. For example, here's the answer that the program, the show provide, and the question is what is Sanskrit? So this the contestant needs to supply this after they receive this clue. And the IBM Watson. So in the chapter 6 of the book, the Watson refers to the IBM computer that compete in the Jeopardy in 2011. Only that, but for current and future application, IBM use Watson for a lot of different analytical program and area like healthcare or the IBM Watson Group. We provide the cloud delivered service, the chatbot, teaching assistant, weather forecasting, fashion, and tax preparation using by HR blog. And I provide two YouTube videos here for you guys if you want to watch. First one is the story about the Watson in the Jeopardy challenge, and the second one is a TED talk about the same thing, the Watson and Jeopardy. And there's some challenges that Watson faced. The first one is language understanding. So you can see here I list the three example from the book. The sentence is in the same structure, but you can see in the first one the meatball is something uh, in the spaghetti. It's a part of the spaghetti, but in the second one the fork, yeah, even is the same structure in the same position, but is have different meaning. The fork here is the tool, the instrument you use to eat the spaghetti. The last one, my friend Bill, is not in the spaghetti or not the tool, but is a person you have dinner with. So for for you, it's easy for you to understand these sentences. But for the computer, if they see the three sentences, it's very hard for the computer to understand. And the other challenges is the open question answering. So it can be anything, like for people, for year, movie, or the concepts. A lot of things it can be answer, and the source is very huge, written document, and is there's no fixed form. The text is free form, so it's hard for the computer to understand and learn from these sources. And the range of possibility is too wide. Thank you. This is my part.
Hello everyone, my name is Van. Now I'm gonna continue our presentation with how Watson works. As you can see from the chart on the slide that generally after gathering thousands of candidate answers to a question, Watson will funnel them down to get the final answer, which is scored most highly by a predictive module. It also performs certain lookups and reverse lookups into databases and dictionaries to collect more candidate answers. Moving forward, which is why it is necessary to do predictive modeling. In fact, there is a serious challenging for the machine to even be confident what kind of thing is being asked for, and that's why predictive modeling is necessary. It is to figure out what answer is correct and achieve its full potential and conquered open question answers. But there's another point that I would like to mention here is the lengthy of the process to figure out what is the correct answer. The machine uses a hundred of methods to search a hundred number of sources to check candidate answers and collect evidence measurements for each one, then score them, rank them by applying the predictive modelings. See, it is obvious that it's really consume effort and time. Then the IBM team considered to use thousands of CPUs to perform the process, which means thousands of tasks can be done simultaneously to speed up the process by using both hardware and software. Next, which is how to improve its performance. The IBM team improved Watson performing by weighting evidence with ensemble modules. They use machine learning to optimally train evidence. It gathers candidate answers and evidence for each candidate, and is ensemble module then score each candidate answer with a confidence level so that it may be ranked relative to the other candidates. The machine will go with the answer having the highest confidence. The next point, which is the ensemble modules, in which Watson incorporates in three ways. The first way, which is combining evidence, it trains a module to score for each candidate answer measured by 100 of methods. The second one is specialized modules by question type. The machine has separate specialized ensemble modules for specific question types, such as puzzle, multi-choice, or date or number, or even translation, etc. And the final one is iterative PhD or predictive module, in which it iteratively filters candidates' answer and refines the evidence, then reassess and refines the evidence to come up with the smallest of candidate answers. Then I'm gonna pass the presentation to Youwei to continue with you.
My name is Youwei, and as my teammates HaPhan and Van already talked about how Watson works and what Watson is and what are the improvements there are for Watson in the future, I'll be talking about comparison Watson to Siri. So Siri handles much more simpler language than Watson does. Siri is used inside our mobile devices to only share general knowledge. Like you can ask simple questions, like the weather, the like buying movie tickets, like also plane tickets, and also asking the time, and also some like funny questions. But Watson is more of like used in applications, business applications, such as healthcare industry. They use Watson to diagnose the patient, and also users can address the device in casual manner with little or no prior instruction. For Siri, Siri is pretty simple to use. Like when you buy an iPhone, once you set it up, you can just ask Siri any questions with no problem. it's pretty easy to use. However, Watson is really hard because it's so complex and the machine is really big. Even now, they are researching in new like less power consumption, like also the smaller Watson device, but it's still not there yet. Also, Siri process spoken inquiries, whereas Watson process transcript questions. Because Watson was mainly built for the Jeopardy game, so there are like lots of external answers, evidence sources for Watson, and then the knowledge base include is much more bigger. Watson contains like so many dictionaries, news articles, literary works, databases, which Siri doesn't have that much. Also, Siri includes a dictionary of humorous canned responses. Um, for example, if you ask, I tried this on my phone. So if you ask Siri, "How old are you?" Siri replies, "Age is nothing but a number, but technically it's also a word." Yeah. So and also another difference is they operate in different domains, and also Apple Siri is they use a bottom up approach. They focus on like they understand like what's going on, but IBM Watson focus on top down approach, which is what's happening next. These are the like um, difference in between the two. Okay, next slide is why is human language such a challenge for computers? Is artificial intelligence possible? The reason I think human language is such a challenge for computers is because the wording sequence, the situational like phrases, also the syntax and slang. Like AI doesn't really have the common sense to understand human language. For example, there's a example online. It says the trophy will not fit in the brown suitcase because it was too big. Because we understand it easily that because it was too big, that means the trophy is too big. So the suitcase is smaller than the trophy, so it can't fit in. But the computer doesn't understand because it doesn't have the experience, and it doesn't. Cause, computer will mess up the it. They will be thinking it's either trophy or suitcase in this case. So because we know suitcase contains things and the trophy normally doesn't. And then we also know how containers works. Like larger containers can't fit into the smaller ones. It's based on our personal experience and which the computers they don't have. And the second one is too much to learn from. As we mentioned before, there are millions of textual sources, written documents, and also for open questions. It's really hard for computers to answer all of them unless they have collected enough data for everything. And is AI really possible? Yes, AI is possible. Consider Watson as the first AI, like the real AI product. Um, but based on my research, AI is split into a narrow AI, which is where we have been right now. It does one particular task. For example, if the recommended playlist from Spotify or spam filter tools or even self-driving vehicles, they are all examples of narrow AI. General AI, we're not there yet. That's the direction we're going to. It's also called strong AI, and it's altogether more sophisticated. It's a system able to copy any generalized task which we ask for. It's really functioning like a human. If you can teach them like how to play sports, they will learn, and then like how to do haircut and how to eat, they will learn that as well. But we're just not there yet. But narrow AI is really what we are right now in the world. And also the last section is going to be moving forward. I think and wait like the main point is predict something other than what's going to happen. So it's all about to decide what next action to take. So we don't want so we want to know what's going to happen, and also we want to know what to do about it. That's going to be the AI moving forward. And also we have to understand the AI and take care of the data, find the process that need the improvements. We can start it low and then keep develop the AI into keep developing the AI in the company and put it more to a powered organization. And we have to be ready to tackle the future challenges ahead. And that's about it. Thank you for listening.